Hey guys, today I want to show you a technique that I think is the most useful and valuable technique that you'll learn in algebra that you'll be able to use in all sorts of different classes, other algebra classes, and especially in different science classes. In fact, this technique alone got me through chemistry. So, it's a simple technique for making conversions. Now, to convert from one unit to another takes advantage of two major key ideas. The first idea is that whenever you multiply something by 1, it doesn't change. And the eye-opening thing is that there are actually many different ways of writing 1. You, of course, probably know that you could multiply by a fraction like 4 over 4. Since you have the same thing on top and bottom, that's obviously equal to 1. But what's not quite as obvious is that if you write something like 12 inches and 1 foot, well, that's the same thing on top and on bottom, and that fraction is actually equal to 1. The other major advantage that we take advantage of, the other major idea that we take advantage of is that when you've got factors on both top and bottom of a fraction, those cancel out. We've seen that recently. When you've got x's on top and x's on bottom, they cancel out. We're going to think about it the same way, only instead of thinking about variables on top and bottom, we're going to be canceling out units on top and bottom. So let's show you with a quick example. Let's answer the question how many seconds there are in a day. So to start one of these conversion processes, I usually start with the given. In this case, I've been given a day. 1 day is my starting point, and I need to convert that into seconds. So I'll start by writing 1 day. Notice how it looks like it's above a fraction? Now I'm going to multiply that by a conversion factor. Specifically, I know that there are 24 hours in a day. And do you know how many minutes there are in an hour? That's right, Johnny, 60. So 60 minutes in 1 hour, we can put that factor down. And how many seconds are there in a minute? Great, Julie, there's 60 seconds in a minute too. So notice how I've tacked on a couple different conversion factors. Now I want to show you something really cool about these. If you notice, I've got a day that's on top, and I've got, in this fraction, a day that's on the bottom. If those were variables, I would cancel them out. I can do the same thing with units. So, days cancels with days. And if you notice, I've got hours and hours canceling. And I've got minutes canceling out with minutes. And in fact, the only unit that's left here is seconds. So my answer, if I were to simplify this like we've been doing recently, is going to be in seconds. And to get the number part of it, we just look at the numbers involved. 1 times 24 times 60 times 60. So 1 times 24 times 60 times 60, that's equal to 86,400 seconds. So that last example showed a couple different conversion factors. A conversion factor is simply two equivalent values written as a fraction. So that fraction, therefore, is equal to 1. We used, in one case, 60 minutes is equal, or 60 minutes over 1 hour. That's one example of a unit fraction. It's a unit because they have units in there, but it's also a play off of the word unity. Unity means 1, and so a unit is often a 1. Now, 60 minutes per hour could also have been written like this. 1 hour is equal to 60 minutes. This fraction is also equal to 1. And which of these fractions you use in a scenario depends on whether you're trying to convert from hours into minutes or whether you're converting from minutes into hours. The key to deciding which one you already have, the key to deciding which one you use is to write the one that cancels out the unit that you're trying to cancel out. So since we had hours before and we were trying to convert that into minutes, hours was what was on top, and so we chose this fraction because hours and hours would cancel, and that would change me into minutes. Now, I like to think of these unit conversion problems as thinking about playing the game dominoes. When you play the game dominoes, you often have lots of dominoes that you can choose from, and specifically, you need to play the domino that kind of matches the last domino that was played. That's why in that last example we had minutes. That's why in that last example you saw kind of a chain of unit conversions. As we worked our way down the line, we just kind of added another domino onto the stack until eventually we got to the unit that we were interested in. Now, there are tons of conversion factors, or AKA dominoes, in my opinion. So let's just list a few of them that I think you ought to know. For distances, of course, you should know how many feet there are in a mile. If you don't know that number already, memorize it. 5,280 feet is equal to 1 mile. You also ought to know a couple of the things from the metric system. That is, 1 meter is 100 centimeters. And you ought to know that 1 kilometer is 1,000 meters. There are a couple different ways of converting between the metric system and the English system, which is what feet and miles and yards are all about. But the one that I remember the most is that there are 2.54 centimeters in 1 inch. If you haven't memorized that or even heard of that fact before, that's a good one to memorize. It's an exact conversion between the two systems. Now time, there's lots of units of time. Just as a quick example, there's 24 hours in a day, there's 7 days in a week, 365 days in a year. Lots of different ones that you probably already know for that one. For weight, let's see, weight, there is 1,000, let's try 2,000 pounds in a ton. That should be one that you know. And there are 16 ounces in a pound. Also, to get from pounds to kilograms, that one's not quite as nice, but there are 2.21 pounds for every 1 kilogram. Those are a few facts that you ought to know or memorize if you haven't already learned them. And then volume, and I don't mean how loud something is, but volume is how much space something takes up. And these are things like teaspoons or cups or things like that. So there is, say, 3 teaspoons in every tablespoon. I don't remember how many tablespoons there are in things like that, but there are 2 cups in a pint. And let's see, there are 4 quarts in a gallon, and there's lots more. Just to give you a couple brief ideas of some of the different conversion factors that we know. Now, each of these conversion factors can easily be written as a fraction. So if I wanted to use the 2 pounds per kilogram fact, then somewhere in my unit conversion process, I would probably have the fraction 2.21 pounds on top and 1 kilogram on the bottom. Or if I was trying to convert from pounds into kilograms, I would do the other one. I'd put 1 kilogram on top of 2.21 pounds. It all depends on what I'm trying to cancel out. Now, I'd like to do a few examples, and specifically these are questions that aren't technically conversions from one unit to another, but kind of an interesting questions nonetheless. So Usain Bolt was a really fast runner a while ago, a fast sprinter, and I want to calculate how many miles per hour he is sprinting on average when he does his 100-meter dashes in less than 10 seconds. So to answer this question, I'm going to start with what I've been given, 100 meters and 10 seconds. And remember, speeds are when you have distances divided by time. So I'm going to start by 100 meters divided by 10 seconds. And I'd like to convert that into speeds we're more familiar with, miles per hour. So I need to convert my meters into miles, and I need to convert my seconds into hours. Maybe I'll do the seconds into hours a second. We don't have to do these at the same time. We can do one now and then another one later. So to convert from seconds into hours is simple enough. We've done that one a little bit before. There are 60 seconds in a minute and 60 minutes in an hour, so that suggests I'll need to use 2 unit fractions. Let's write the 60 seconds into minutes, and specifically I need to write the one with seconds on top because seconds was on bottom, and I want seconds to cancel out. So that puts 60 seconds on top and 1 minute on the bottom. Now seconds cancels with seconds. And let's do from minutes to hours. 60 minutes are in an hour, and that's the way I need to write it, with the minutes on top to cancel out hours on the bottom. So minutes and minutes are gone, and now I've got the correct time unit of hours. Now I've got to find a way to convert meters into miles. Now, I know a fact about meters. I can go from meters into kilometers. There's 1,000 meters in a kilometer. That's what kilo means. And so let's put that fact in. 1 kilometer is equal to 1,000 meters is the one I need. Notice this time I put the number 1,000 in the bottom, and the only reason I did that was because meters was on top already, and I need it to cancel out. So meters cancels out with meters. Now I've got a speed that's in kilometers per hour, which is great if we live in Canada, but we don't. We live in America, and so we need to figure out what that is in miles per hour. And to do this final conversion from kilometers into miles, I don't know what that is exactly, but I have run a couple 5K races before, and I know that that's 3.1 miles. That fact that I know is a unit conversion. I can write 5K, 5 kilometers specifically. That's equal to 3.1 miles. And so the kilometers cancels out. Kilometers cancels out, and unit-wise, the only units I have left are miles and hours, which is what I want. And so to get my number part of my answer, any of the numbers that are on top, I'll multiply together, and any of the numbers that are on the bottom, I will divide by, and when I'm done, that number is my answer. So let me grab my calculator. And we'll do the numbers on top, 100 times 60 times 60, also times 3.1. And then I'm going to divide by any of the numbers that are on the bottom. So I will divide by 10, divide by 1,000, and divide by 5. And it looks like Usain Bolt runs at an average speed of 22.3 miles per hour. That's awesome. Now, some people like to multiply all the numbers on top and then multiply all the numbers on the bottom and then divide them, kind of in a 3-step process. I personally don't know why they want to do it in 3 steps, but you could do that. You can do 100 times 60 times 60 times 3.1, and then do 10 times 1,000 times 5, and then divide those two numbers. Notice you get the same answer, but it took 3 steps. If your calculator can handle it in 1 step, why bother typing it in 3? I don't know, but I've seen that, so I thought I'd show it to you guys just in case. So 22 miles per hour. We'll answer one more question, and then I'm going to call it a night. How much does it cost for my car with a gas mileage of about 24 miles per gallon to drive for 1 minute at 55 miles per hour? So there's a lot of facts in here, but I want to highlight 2 of them. 24 miles per gallon is essentially a unit fraction. If I use 1 mile of gas, I go 24 miles. If I use 2 gallons of gas, I go 48 miles, and so forth. That's a fraction. The other fraction I have here is 55 miles per hour. It's a speed, it's a rate, but it's also a unit fraction. I can use 55 miles on top and 1 hour on the bottom, or I can use 1 hour on top and 55 miles on the bottom. It depends on the scenario. So what I'm going to do is I'm going to start with a minute, and then I'll see if I can use these facts, or if I can't use these facts directly, I'll get to the point where I can use them and see if we can calculate this. So we start with 1 minute. The speed here, 55 miles per hour, is kind of related to time. Maybe I should convert minutes into hours, because then I can use this fraction, that domino. So to do that, let's do 60 minutes in an hour. Notice I wrote the minutes down below to cancel out with minutes here. Now I can write the fraction 55 miles on top and 1 hour on the bottom, and the hours will cancel. And now that I've got something in miles, I could probably use this fact for how many miles per gallon I've got. So specifically, the 24 goes with our miles, so 24 miles will go on the bottom, because miles cancels with miles, and that gives me gallons of gasoline used. And if I quit right now, I would figure out how many gallons of gas I use every minute while driving down the road. But I wanted to know how much it costs for me to drive for a minute down the road. And in order to use that, I'm going to have to use another fact, and that is the cost of gas. Right now, gas is a little bit more than $3 a gallon. I think it was about $3.32 on my way home. So let's use that price as a unit fraction. Specifically, it's $3.32 per gallon. So gallons cancels, and the only unit I have left is dollars. And number-wise, let's multiply the numbers on top and divide by the numbers on the bottom. We've got 55 times $3.32 on top. We divide by 60, and we divide by 24. And remember, this is in dollars, and so it looks like it costs about 13 cents for every dollar, or excuse me, 13 cents for every minute that I'm on the road. Since my drives into school usually last about 30 minutes each, let's multiply this by 30. And it looks like it cost me about $3.80 to drive into school one way, plus another $3.80 to drive home, or roughly $8 a day in gasoline.